Okay, so what we're given is a two-phase motor with 4 pole pairs, or 8 poles. So using our equation, steps per revolution, S is equal to 2pn, we find that there's 32 steps per revolution without gearing, but when we add gearing, we find that there's 2,048 steps per revolution. Okay, so here is our wiring setup. It's all centered around this L293D H bridge. So because we have a two-phase motor, we're going to need 2 H bridges. We need 1 H bridge per each phase. Pin 1 and pin 9 are enabling / activating the driver channels for the first H bridge and the second H bridge. Channel 1 and 2 is 1 H bridge, and channel 3 and 4 is another H bridge. In that sense, a two-phase stepper motor is the most that this chip can support. Each H bridge can be controlled with just 2 inputs. So since we have 2 H bridges, we need 4 inputs. Each H bridge also has 2 connections with the motors. Since we have 2 H bridges, we're going to need 4 connections to the motor. And these are grounds, and then this is the supply for the chip itself, and this is the supply for the motor. Our microcontroller alone can't always provide enough power for a stepper motor.
It's good enough. All right, I'm picking some arbitrary angle, and this is like one of the faster speeds I can do. I'm just going to choose clockwise arbitrarily. Upload. Here's my serial monitor. It prints every step. And here I'm rotating at 30 degrees at a slower pace, going counterclockwise. All right, so here I'm going to demonstrate part 2. It's so start with 45 clockwise. Counterclockwise too. I'll now demonstrate 90 degrees. And I'll do it counterclockwise as well. Here's 180 degrees, clockwise. Counterclockwise. $360 degrees. I'm just gonna try to make it a little faster. And yes, it can also go counterclockwise. The only difference from clockwise and counterclockwise is rather than going from in the order of A, B, A prime, B prime, we're going B prime, A prime, B, A.
There's an order to which I want to activate the different coils, and that order is A, B, A prime, B prime. Pretty much the same as given in the pre-lecture videos. And then I just set, in setup, I just set pins to output. And here's the loop. So there's 2 if statements, if the direction, and they're basically identical. So let's just go over clockwise. So what happens is I'll set, there's 4 different pins. First I'll set them all low, and then I'll set the first pin high. And then when that loop redoes, I'll set them all low again, but now I set the second pin high. And then that loop will go again, and I'll set everything low, but now the 3rd pin gets high, and the 4th, and that's how it iterates. And I'm counting the steps along the way, because if the step count exceeds the step count needed to get to my desired angle, then I run this separate function that just goes to the serial monitor and states what we've done, and it resets the step count as well.